So I'm not gonna stay here for a long time today. I'm just gonna show the progress that I made so far. And I think that's gonna be a lot harder than I thought it would be. And so far, I think that the reason why is because of the way that Godot's data structures work, the way that they created things, which is the transform 3D, the bases, which are basically the fundamental things that they use to manipulate the Node 3D class and the camera 3D. So because I try to, so I'm gonna explain. First, I'm gonna wait to see if it's streaming. Then I'm gonna explain the confusion that I had in the beginning, which now is more clear, but yeah, for some reason it's still not working. So that's what I want to figure out. And I'm going to spend some time studying Godot's source code to see if I can understand the way they did it, because the thing that I'm trying to achieve is the same camera that they have on the editor. So panning, zooming, and orbiting the view. But if it takes me a long time to do that, to be able to do that, then I think I'm not gonna do it. I'm just gonna leave it the way that I have now, which is based on the same way that I've seen from most places, the way that they do it. And then I'm gonna just move on to other things. And the stuff that I was working is so basically those are the two main things that I had to do. One is to figure out the rotation, the camera rotation, and the other one is to figure out how to put the arrow on the surface of the sphere and not inside of the sphere. And that's the stuff that I was able to do just now. I think is working, which was a kind of another annoying thing that I faced that I don't understand why they did it like this, but which I just realized right now, right before streaming, is that when you increase the size of the radius of the sphere, it only grows the width and not the height. And I don't understand why they did it like this, but luckily it seems to be working now. All you have to do is just set the height to 2 times the sphere, and then it maintains the thing. And one of the reasons why they might do it like this is because they allow you to edit the shape, obviously, but I still don't understand because the default in my mind should be that since it is a sphere mesh, you should always maintain the geometry of the sphere. It's kind of a little bit weird. But hopefully this is gonna work. I tested with two sizes, and I think I'm just gonna maintain one size that seems to be. I still don't know very well what size people usually use. They do everything based on the metrics system, but I don't know what is usually the size that people choose to put stuff. But I think I'm gonna leave the size that I have now and see how it looks on the camera. But it seems that I'm gonna have to move the camera away very far with the size that I have now, because the things in relationship to the camera, the things seem to be very big. So I'm just gonna show what I have. So like I watched a bunch of videos and then I also read, and I just realized as well that it's scratch a pixel, not scratch pixel that I always say, but it's whatever. So basically, yeah, this site here has a bunch of useful and helpful articles. So I remember this as I was trying to solve the orbit thing because mine wasn't working. And then I tried this approach here and I tried other approaches as well. And I think that I did everything correctly, but obviously not 100% sure. But the way that the visualization seems to be there on the camera that I have is not the same way that they do it here. And I downloaded the source code and I tested on my thing there as well, my computer, and still like, yeah, this is basically what they have, which is not exactly what I wanted as well, but it's basically what they have. And I did pretty much what they do here, and it didn't work there. And I tried a bunch of different ways. So this was one thing that was confusing me because it's been a long time since I have done this thing here. But I realize now that what I did here was not to move the camera. As far as I understand now, maybe I'm still can be wrong, but based on the source code there that I've seen, I think that what I'm doing here is just rotating the objects and not the camera. So it's different than what I'm trying to do there. And on Godot, I also think that they do rotate the camera, but it's like the name of this is called arc ball. Is you have to rotate the camera and translate the camera. So you can imagine that it's like the camera is walking along the path of a sphere in 3 dimensions. And if you just do the rotation, I think what it does is just rotates the camera and the camera stays in the same place. So it gives the wrong sense of the visualization. And that's the thing that was confusing me a lot. And based on what I did here, it still seems that I'm only rotating the camera because that's what the people in the tutorials and everything tell you to do. So I'm not 100% sure what is going on because that's basically what Scratch Up Pixel does as well. They use 2 quaternions to create this rotation here, and I try to do the same on the code that I have there, but it doesn't work. It still gives a different rotation. So I was trying to achieve this one first, so that then I could try to see if I can do their arc ball. But even that one, it seems that it only rotates the camera, which makes sense to me. So like I don't really understand very well as well why this one works. And my guess is that it might be because this one uses ray tracing to render the thing, but I'm not 100% sure if that's the case. So I'm just gonna show what I have there now. I finished all the getters and setters as well and everything. So basically I have everything now. The only thing that is left is the camera orbiting, and then after the camera orbiting, which is also another thing that is going to be very hard, which is figuring out the Barnstad solver C++, because a long time ago, and it's very confusing. But basically, you need to create a arc tree, which is a 3 data structures that breaks down 3-dimensional spaces in cubes, and then it calculates the forces and velocities based on the area of the cube or something like that. So you create the arc tree, and then you do some stuff with the arc tree to do the solver. But I'm not sure how I'm gonna do that. I'm probably gonna try to create the arc tree first, and then see if I can, because I couldn't find any solution that explains very well, like only on C++ how to do it from scratch. So I'm gonna have to break down into multiple different things, and then try a bunch of different things, probably which might take a lot of time. So this is the reason why I'm not really sure if I'm gonna spend a bunch of time trying to figure out the orbiting camera, which is just very annoying. But I do think that I need to study the way that Godot does things, even though I don't like it that much. It's kind of frustrating to me because it's very confusing the way that they put the names there. But I think it's too much work to just change everything, try to change everything, so that it uses normal matrices instead of transform 3D in basis. It's not that big of a deal either way. I think it might be just because I'm not used to it, and then once I study more and understand like the basic stuff that they do, and like I change the way that I think, then it might get easier, but it's not very intuitive for me. But it seems here that it is working here. Like it's right on the surface. And the way that I did this was I tried a bunch of different approaches, but because like the difficult thing about this, and it's actually I think I kind of got lucky here because it is actually very hard. Because the hardest part is that you need to take the curvature of the Bezier curve into account so that the angle that it hits the surface is correct, so that it seems that it's going to the center of the sphere. That's the thing that I was having the most trouble with. Because there are several different ways to do it, I think, and I was trying to think about what is the best way to fit the calculation inside of the curve. But then I realized that in order for me to fit the calculation inside of the curve, I need to calculate the curve first, and then after calculating the curve, I have to calculate a new curve with the position. Because basically what you need is the tangent, the last tangent, which is roughly what I did here. I'm gonna open the other project, the front end, because I remember as well as I was looking at the front end here that's basically what I did, but I did it in a different way because in the front end I'm separating the arrow from the edge. So the arrow was its own mesh and the edge was another mesh. And then what I'm doing is just setting the quaternion for the arrow mesh based on the arrow rotation. But I get the arrow rotation based on this. So I create the curve first here, then I get the rotation based on the curve that is created. So this curve here is a class from 3JS, and then they have a method that allows you to get a tangent at a specific point. So I'm basically getting the tangent. And this is the thing that I don't think you can, like, there isn't a way to get away this, because if you only have the position of the radius, there is no way for you to know at what angle the arrow should go to the surface. So obviously you can, in any X, Y, and Z direction, you can decrease the radius, but then the arrow is going to be kind of weird, because it's going to, depending on the rotation of the sphere and how the arrow is getting to the sphere, is going to is going to point at the sphere in a weird way. So I think that the only way you can do it is getting either building the entire curve or getting the final tangent of the curve, because that is going to signal the direction, and then use that direction to calculate the offset from the sphere. Which is basically what I'm doing here, I think, because this one I don't remember really well. I think I just tried a bunch of stuff and then this one worked, so I just went with this, but I didn't understand very well. But I think it's just setting the quaternion based on the tangent of the curve, and then I build the curve again. So that's basically how I solved here. And here, the way that I solved is just by creating another function called getLessTangent. And then instead of running everything, I just get less velocity of the curve by passing the start and end points, and then I normalize the velocity, which is going to be the last tangent of the curve. Then from the outside, I just do this calculation here, which is multiplying the last tangent by the target radius, because the last tangent is already normalized, so it's just like the unit vector that contains the direction of the curve. So you multiply by the radius, and then you decrease by the target position. So that's basically subtracting the sphere radius, the center of the sphere with the radius on the direction of that the curve is getting to the sphere. But this is not 100% precise, but it works fine. And the reason why is because then I have to calculate the Bezier curve with this other thing here. So I'm calculating the tangent passing 2 different points. So there's an offset between the Bezier curve that is built, because this Bezier curve is built, the tangent is calculated based on the Bezier curve that would go from the beginning, from the source node to the center of the target node. But then the actual curve that I'm building is from the source to the surface of the sphere. So it's just 2 different Bezier curves, but I think it's pretty close, so it doesn't matter that much. And it seems that it works there. So let me show the camera. Also, I decided to change the way that I was doing the zoom. So the way that I was doing the zoom is just taking getting the vector of the direction from the mouse event to the center of the camera, and then moving the camera towards that the mouse based on the scale. So both on the 3 axes, I was moving the camera in the direction of the mouse. But I decided that I should only increase the Z, because it seems that it works fine this way, and it is a way that I have here that is basically the 3ds implementation. It just is zooming on the... It's just dolling, actually. So it's just getting closer to the Z direction. And the reason why I thought that I had to do the direction from the camera to the mouse position is that I remember when I was creating a project to study this stuff with everything from the scratch, and I was using the matrices that I got from 3PP, that when I zoomed into the scene, the zoom didn't take into consideration the it always zoomed in the same place, basically. But I think that I got confused there, because I don't remember if I had the panning at the time, but maybe I did. So it might be something to do with the camera, the way that I was doing there before. But it would basically, regardless of where the thing was at, when I zoomed, it would put the triangle that I had in the center of the visualization. So it was just recentering the camera to the center, to face the triangle, regardless of the position. So that's the reason why I thought I had to do the direction. But now I think it's just better and simpler to do the Z. And this is another thing that I realized. The reason why I was feeling that depending on the angle you zoom here, it gets really weird because you can't get very close to the camera. And the reason why I think is because of these transformations. So if you rotate the camera, then the z-axis changes, and because the zoom works basically based on the z-axis, if you rotate and you do some transformations, then it stops allowing you to get very close to the visualization because the camera is probably aligned with the z-axis in a weird way. So it is kind of annoying, but I think that's usually how everyone does it. So because this is another very difficult thing about these camera movements is that if you do the transformations on the camera matrices, then it becomes very hard to think about how to maintain the panning and zooming from the other functions, because obviously like you have to find ways that are not based on the axes themselves, and I think that's probably, I wouldn't say, I don't think it's impossible, but it's probably very hard. But here the issue that I have is that so it is doing the rotation, but the problem is that it shouldn't move the visualization. It should move the camera around the visualization the same way that the thing here does. So when you do this, it's like it's rotating the camera around the center point and not rotating the visualization around the camera. I think that's the difference. But based on what I've seen there, they use pretty much the same idea. So I'm not 100% sure what is going on. The only thing that makes sense to me is that it's something related to the way that Godot setups everything. Because the one thing that I couldn't figure out from the way that they do it is that they don't change the states of the camera directly. They create another data structure which is called cursor, and then they probably use the cursor somehow to update the visualization. So they're not using a camera directly. So it's hard to know. So the way that they do it is just by updating the values of the cursor. But it's hard to know if how do they use the values of the cursor to change the visualization. So that's the problem. But basically they do the same thing that everyone tells you to do, which is just rotate on Y and X based on the position or the relative position of the mouse, multiply by a certain float, which is just the magnitude, how fast you want the thing to rotate. So it's just basically doing a simple rotation on the Y and X axis. And so, some times some situations I've seen that they change so they rotate the Y axis by the Z value of the mouse. I think that's probably the most common way, and then the other axis the other way around. So I think it was it's basically this function here. So the thing that they changed that I think I tested sometimes, but I don't think it matters that much. It's just this value here, which is basically just the sensitivity, like how fast it's gonna orbit this stuff. But it shouldn't change the behavior of the thing. So I don't know if I'm like, because here is clearly not working correctly. That's the problem. I don't remember if I changed something there as well. It feels very weird. And then they are just changing this value of the cursor here, the axiom, and then there isn't a way to see how exactly this is going to change the visualization there at the end. And this clamping here is just it's like I said, the x value of here is going to be determined. It's going to determine the y rotation, I think. Yeah, something like that. So I think yeah, that's basically, yeah. So it clamps the y rotation. So this clamping here is just so that you don't put the visualization in, you don't make the visualization inverted, but it doesn't have anything to do with the actual movements of the thing. just for limiting the scope of the rotation. So I want you to understand how this cursor is impacted there. And the stuff that I'm trying to do is here. I think I changed a little bit. So I did a bunch of variations, that's the thing. But here there's a tutorial there that tells you to translate the camera into a distance from the z-axis, and then you do the rotation, and then after you do the rotation, you translate the camera back again to the original place, and then you normalize. But there are other places where they tell you to just rotate, which was what I was doing here. Rotate X and Y. And the other thing that I learned is about polar coordinates. So one thing that I was trying to do, and I still don't understand very well why it doesn't work, is to translate the 2D coordinates from the mouse into sphere coordinates, so that the movement of the mouse is translated into a rotation in the sphere in 3 dimensions, and then I can both rotate the camera and also translate the camera. So that, because in my mind, that's what makes the most sense if you want to orbit around an object, to have to rotate the camera, and then the order matters, but I'm not really sure if it's gonna change. I think it does change a lot, so I think probably you should translate first and then you rotate. That's how probably most likely to work. So, but I tested this as well and it's not working, so I'm not really sure why. But this is basically the formula here, and the only thing that's missing here is that you need to multiply by radius, which I also tried, but then it deviates to infinity. Like it just zooms out, goes to whatever place in the visualization. You lose track of the objects there. But the radius is just probably the distance, obviously. So it is what's going to determine the pivots of the visualization, let's say. And this theta and phi, the names I just got from Scratcher Pixel, but it's basically the same thing. So this is another way that I was trying to do based on the Scratcher Pixel. That's how they do it there. So just multiplying the relative position, the delta position of the x and y, getting the negative value, and then creating a quaternion on the x based on the y position and on the y based on the x position. Then you multiply both of them, and that's the rotation, and then you set the camera rotation. This is the part that it might be. I think that this was probably a problem because when you set the quaternion for the camera, it just compounds, and then like the other movements might be kind of weird after you set. But I think that is not the issue. That because this one was also working fine when it comes to the rotation around, like just a normal rotation, but it wasn't giving the sensation of orbiting around a point. It was more giving the sensation of rotating the camera itself. This is the stuff that I don't know what I'm gonna do about it. So the only thing that makes sense in my mind is that something you have to do, because I still don't have a clear picture of how the final matrix from Godot is gonna be to determine the camera position. And that's one of the things that I had a problem with since the beginning. Is that a lot of these transformations are on the Node 3D class, and it feels kind of weird to me. Like it feels that it makes more sense in my mind for all this stuff to have like matrices, matrices classes, and in the same way that they have vector classes, have the matrices classes, and then on the classes use the matrices to create different member variables and then update the member variables accordingly. So I don't know why they chose to do it like this. But basically this movement here is basically the same that I get from the quaternions there, I think. But it doesn't feel like it is, like it feels that the camera is rotating, not the thing. So I'm not really sure what to do about it. I'm just gonna show without the... I'll probably dedicate this... I'm probably gonna stream tomorrow, so I'm not really sure though, but if I stream tomorrow, I'm probably gonna just do like 2 days of this, trying to understand. Or I'm gonna think about an hour limit of how much study I'm gonna dedicate to figure out how Godot does it from the editor. The thing that it might be worth it to do it, that makes me think that it might be worth it to do it is that I don't think this is gonna work with the. Is that I have to understand the Transform 3D and the basis anyway. So this might be like a good opportunity to spend a bunch of time understanding usually what functions they use from these classes should do the transformations. I know that the X form, one of the ones that I'm very confused by is the X form function, which I don't know what is the purpose of, but they use it all the time. So yeah, I think after I show this, what I'm gonna do, I put some breakpoints here. I'm just gonna go over with the debugger, and I'm gonna see. I'll try to see if I can understand what exactly is going on. So how to. I need to think about what exactly I need to know as well. Um, Probably. So I'm gonna close this one. Just I'm gonna show the. Hopefully, it's still working here. Yeah. So basically, I think I can open it from here. Yeah, this is the compiled from Scratch a Pixel. I think it's Shift, it's Alt. Yeah, Alt and the wheel to track. Then right button and Alt to zoom in out and out to dolly. Oh, I think what was the tumble? Yeah, tumble is Alt and left mouse button. So that's basically. This seems a lot better to me. And this, I think, this is the same behavior as getting on 3GS, but it's different behavior from the one that Godot has, I think. So I'm gonna show this one. I'm gonna test the other thing there, and after that, I'm gonna open the debugger. Yeah, so I have to think about because like the thing that makes this difficult is that I don't know how to go about clarifying because like the problem is that the editor like I'm pretty sure I'm pretty confident but I'm not 100% sure that this is the class that is responsible for creating the visualization on the editor, the camera movement, but I'm pretty sure it is. But even if it is, I, I'm I have to think about how to understand how the values change, the but only in relationship to the camera and not everything else. And this is a problem because obviously the visualization is related to everything else. So after doing that, after clarifying how the thing translates into matrices, I have to understand how to translate those matrices into the camera class that I have there. So I don't know what's the best way to go about doing this. That's the problem. But I think probably stepping over with the debuggers a good start. And I've seen some functions there that it seems that are the functions responsible for creating the final state, let's say, and that they use the other values, obviously. So I search for the values that it changes there on the cursor class. It's basically the rotation and the normal XY. And I search for the points where it actually assigns the value to that, which is just on the events. So it's on the zoom events, the pan, and the orbit, basically that it changes those values. And I think that there is another function that uses all those values to build the final camera matrix. But I'm pretty sure I tried to also use that on the thing there. So I found a place that they create a transform and then they update the transform 3D based on these parameters, and then I tried to implement that on the function that I have there, and it still wasn't working. So I'm not really sure what's going on. And the string to string still works, but all fucked up. And it's on the wrong thing as well. So on this one is very simple the way they did it here. So this is the condition for the camera tempo. Then this is how the structure that they use to keep track of the movements. Usually they call like this the theta and phi for the polar angle coordinates. So basically the way that it works is that you create two different planes of rotation, and then z-axis is going to be determined by the cosine, which is the distance from the origin, which is kind of confusing to me. I've seen videos about the derivation, but it's still kind of confusing. I think there are more ways to derive that, because when I was trying to think from the top of my head, I came to similar conclusion, but it was different equation. I'm not really sure if that one is correct, which is basically like, in order to have the movement of the sphere, obviously you need to have 2 degrees of rotation. But then the problem is that you have like, in order to do the 2 degrees of rotation, you need 4 values, obviously, because it's x and y on both. So the problem is that one of the values has to be like the bridge between the two, let's say. And I think that's usually, people usually use the z value for that, and that's why the z is the different one. So here, for example, like both the x and y is just variation of the cosine times the sine. It just gives the rotation of the point. And something that I was confused by, but now I think I understand better, is that the cosine is actually the x, and the sine is the height, even though it's kind of confusing the function. Because usually you think about the sine function as being the height. So based on the images there, is represented on the opposite side, the sine. So yeah, I'm still trying to memorize this because I forgot. I always forget which one is which. But I'm pretty sure that sine was supposed to be the opposite side of the triangle divided by the hypotenuse. I took a picture there, so let me see if I can remember. I took a picture and I put on the Anki, which is the next thing that I'm doing. Because coseconds and cotangent seconds are also very... Those ones I didn't... I don't remember studying them very much. I think the ones obviously that are most used are sine, cosine, tangent. So I wanna see if I can memorize them now. Because it's probably... I'm not pretty sure if it's very used, but I think it is useful to know them by memory. And this one is just... I don't think I have the sine thing there. That's basically how it's represented usually. So the sine is on the opposite, which is kind of confusing. But I guess I understand because it's saying that the values on this axis are determined by sine. So sine is y and cosine is x. But I think it's confusing because of the way that I usually thought about these equations, which is usually you have the cosine or sine in one side, and then you have the opposites or the adjacent divided by the hypotenuse. So, and then I was thinking about like, if you want to isolate the hypotenuse, then obviously you're going to multiply, you're going to divide by the cosine. Yeah, but it's whatever, just details. So guys, I'm going to, last thing that I'm gonna do is just to comment all of these out and just do the simple one there. Because it's basically the same thing, I think. But, so let me see if it is the same. Just rotate by X and Y. Just puts the minus here. So I'm not doing anything on the camera besides this now. And I think it's basically gonna be the same thing. And then last thing, so this one is basically just getting the negative x and y, multiplying by a value to determine sensitivity. And then this one is the one that updates, and here they just basically do what I was doing there because I copied from here. So it sets the x based on the y value there, the y movement. Set the x-axis of the continuum by the y, and the y by the x here, and then you multiply the two to get the rotation, and then I think here they translate the continuous through the matrix for 4x4, but then they multiply this rotation matrix to get the camera, or decompose the camera. Yeah. Decompose the camera with this rotation matrix, which is basically going to be the values outside of the diagonal of the matrix. The other ones are the position. So the rotation matrix is usually, I think it's always some variations of sine or cosine along the like upper parts and the bottom parts. I have pictures there as well. Now I don't remember. Here. Yeah, these ones. I think it depends on the framework you're using as well, because the frameworks change between row major and column major, which is basically how they determine what direction to put the axis. This is also from Scratch a Pixel as well. But obviously, when you multiply a position by these values, it's just going to give that equation there. That is multiplying the coordinates by cosine and sine. I think it decreases on some of them. It decreases the sign. So let me close this. And this one is the one that I'm gonna. If I spend too much time trying to do this and I can't do it, then I'm just gonna move on to other stuff. It's not worth it. And the panning and zooming are the most important ones. But rotation is nice to have. So I'm probably gonna leave the rotation the way that it is there. I fucked up and then just not use it. And if I build something, then I see that is very useful, then I can spend a bunch of time trying to understand more how does Godot does it, because that's basically the way that they have there is exactly the same way that I want to do it. So I think panning and zooming is very accurate. So the only one that's seems to be very off is the rotation. Penning might be a little bit off as well, but I don't think that's is that much. It's probably basically the same thing. I don't have that much time now. And this is basically the list I have here. Oh, I forgot to test what happens. So before I realized as well that I was not updating the control points when I sent the curve, so the shape was kind of weird. So when I had two nodes touching each other, it was making a big curve to get from one to the other. So I haven't tested after I updated that what's gonna happen, because also if the path is very small, then I don't think it's gonna. I assume that it's probably gonna do a curve as well, but I didn't test to see what's gonna happen. So it's basically the same thing, and this way is a lot more simple than the other one. So and I think this initially I thought that this was weird. That's when you zoom, when you rotate and you pan, it does the rotation as well. But I think it's normal because when you do it here, is the same thing. So when you rotate like this and then you do the panning, it also rotates the thing because obviously the view is changing. So it makes sense that it's going to rotate depending which kind of which angle you are from the camera. But I know that this it seems very off as well. So I know there's something wrong here. And I don't think it's just sensitivity because the movement seems different. But maybe, yeah, maybe it's just also only like perception. It might be the same thing, just different thing there. So I'm gonna run the debugger. I'm not gonna spend a bunch of time here because the timer there is already off. So 7 minutes. I think I'm gonna spend half an hour more than that. So I'm gonna think about off stream how much time to devote to this overall, just see if I can do it. And if I get past that time, so I'm gonna measure on the clock the amount of time that I spend studying this. If I get past the time that I set for myself there, then I'm just gonna move on to the rest of the list here. So the next, which is kind of weird because it has been a long time since I've been studying this, so I don't even remember really well anymore what I was doing. But I think the next big thing is gonna be to try to implement barn sets. So incorporating the destructors, I hope it's not gonna be that hard. I assume it's not gonna be that hard as well. Just free memory for the barn set struct. And then I need to put everything together on the scene. Yeah, so the part that is going to be kind of hard as well is that now I already forgot. Like this is another big thing, which is setting the creating a function to set the names of every node from the code, so I can differentiate them on the editor. And then remembering how to go about structuring the functions there on the headless mode to build everything from the source code. I think that's gonna be annoying. And also, probably I'm gonna spend some. Not really sure if I'm gonna string this. Maybe, but yeah, I have to learn how. Because one thing that is weird that I tested is that when you put a black background on the scene and you try to visualize stuff, it everything becomes invisible. So I assume that in Godot it's different than other frameworks, that you need to have some light source, I think, to be able to visualize the things. But like I'm trying to achieve is basically this, right? So I think this doesn't have light sources or anything. So I have to see how can I achieve the same thing on Godot. And it seems that it's kind of weird there because you need an environment node, I think, on Godot to do this. So I'm not really sure to go about it. So I'm probably gonna have to spend some time on the editor itself, like doing stuff from the editor to think about how to structure the scene and how the nodes are gonna be, stuff like that, in the beginning, which is gonna be kind of annoying as well, I think. So I might do that before I do the barn sets because it is one of the things that it's kind of annoying because then like it's a lot better to test everything if I already have the visualization this way here, because then I'm gonna have a better idea, obviously, like about the arrow size, the edge size, the radius, stuff like that, how it's gonna look. Because I want to achieve basically this. So then after I do this environment stuff, I think then it makes sense. Sure. Then I put this thing here. I'm probably gonna do the barn sets before because it's more annoying. So see how to put the backgrounds correctly and how to change the colors. Because this is like I think this is the thing about the lighting there is that usually they recommend you to set the albedo color for the materials, but I think that's and there's like so many options there on the materials that's kind of hard to know if it is the one that I should be using or if I should set another color or do something like that. So I'm probably gonna focus on this stuff. Then once I figure that out, then it makes sense to solve the barn setting to see how it's gonna look when I put a bunch of nodes and then I update the physics each frame. And I think it's gonna work on the editor because I'm gonna be setting the process on the constructor of the graph class. So this is the function, I think. So this is from the class that I was looking at there. And I think this is the function that updates camera, obviously, like the name says. But this is the function that is gonna use the stuff from the other functions, from the other functions, based on the cursor that are gonna create the final matrix of the camera. And this is another thing. There are two different cursors. One is the camera cursor, and the other one is the normal cursor. I think the camera cursor is just used for interpolation, so I'm not really sure if I should pay attention to that. So I probably should anything that has camera there, just look into it. Yeah, the thing is, I don't know what they mean by X form. Because I think it doesn't make sense for it to be only associated with the X coordinates. So I think it's something else, but I don't understand why they put this name there. I think this is just updating the coordinates of the current node to global coordinates by getting the inverse of the parents. So you get the global parent transform, and then you get the inverse because you're doing the process. I'm not really sure. No, I think in order to get the to get the global coordinates, you need to multiply the local coordinates by the inverse, if I remember correctly. So it's basically updating the local model, I think, matrix for the camera, I think. I don't remember really well though. If it's should you it's kind of I do remember that you have to maybe you can look into the 3PP thing there. Because I do remember you need to multiply by the inverse of a matrix, but I don't remember which way is the inverse. I think the inverse is going from local to global. Yeah, I'm pretty sure. Yeah, it has to be this because it's at global transform. So I think it has to be. So it checks to see if the current one has a parent, and if it does, then it gets the parent global transform, inverses that, and multiplies by the local transform. And this will give you the coordinates, the global coordinates. Yeah, I think that's pretty much it. And then if you go the other way around, if you want to translate from world coordinates to local coordinates, then you just multiply by the normal matrix, the global transform in this case. Yeah. I'm gonna put another half an hour on my stuff. So the data, I think, is just an abstraction that they use to not populate the namespace for classes that inherit from Node3D. It's basically putting the state inside of the data. And every time that you want to change something, you usually use a function, and the function is going to update the value inside of the data. So you don't get things directly, which is another thing that's kind of confusing, but I think it's not that big of a deal. Because it's confusing because from the other, but I think that this stuff is not doesn't matter that much. But if you want to update from the class that I have there, for example, instead of setting the value of the camera directly from the class that inherits from the camera, you need to assign a new vector based on the functions that you use from here. So get transform basically, or variations of that. So you call get transform, get a new vector, then you change that vector, and then you need to call set transform with a new vector. That's usually, I think, how you have to do it. So, interesting. Yeah, so this is the function that I copied, I think. So this is supposed to take the cursor and transform it into the camera transform. But I'm pretty sure that I tested this. So I copied this function here, and then I put it there on the thing that I have. The only difference is that I got the camera transform from the current class, which is the camera. But it might be because I fucked it up on the translation there. So this is the thing. So I have to see the value of this. Yeah, because the problem is that I'm not really sure if it's calling this with the. I think now it's calling with the camera cursor, which is not going to be the actual cursor that I need to look at. So, but maybe it's very similar. I'm gonna copy this stuff there on the file. I'm gonna try that again. It might be because I translated the values in the wrong way. So, because like, since on the class that I have there, I was getting the transform from the camera. So, I don't remember if I erased this. I think I erased this attempt. Yeah, I was getting basically like this. So, getting the transform like this, and then I copied the function there. I copied this values here, replacing that transform. But then here it doesn't make sense to, I think it doesn't make sense to translate for the cursor position because I think the cursor position is just going to be the position of the camera, where the camera is supposed to be. So since I'm already getting the transform of the camera, I didn't do this one. And then the only thing you have to do is just translate based on the distance, which is the focal point of the camera. And I think here I put a vector 3 with only a z direction, which I think it makes more sense. No, actually, I think this is a float value. So it just puts the value of the distance you want the camera to be. So I think I put -15 here or something. And then I just copy these values here and then -15. And then these values here I got from the orbit function there, which is the one that changes its values on the cursor. Is the X and Y rotation. So I did this pretty much, but still wasn't working. So maybe it is working. It's just like I don't know. So is the 0 vector? 0, 0. I think I need to spend some time on this function. So this is one of the things that is confusing that I said. This transform 3D, as far as I remember, is going to be made up based on this basis, which is a matrix 2 by 3 matrix, and our origin vector, which is vector 3. So the composition of both of them makes a 4 by 4 matrix. So we have a 3 by 3 matrix, which is the basis. Then you have the vector, which is the origin. But this makes it very confusing to me. So like the problem is that some functions are on the basis and other functions are on the other classes. So I don't know, it feels weird. It feels that something like the separation is not like it's different than the other frameworks, all the frameworks that I've seen so far. So these functions here basically they're ones that I want to clarify as well. What the fuck is X for? Just doing the dot product with the vector. So the basis 0 is the row, I think. So it gets the first row, the matrix. The way that I usually imagine, so the way that I think this works is that usually we're gonna have like the state of the either local position or world position is always the same. It's gonna be held by the 3 by 3 matrix, where the diagonal is the x, y, z coordinates, and the other ones are like transformations that you do. And then the other, actually, no, I'm not really sure if it's gonna. No, it is, yeah, it is 3 by 3. So the other vector it would be the one that has the translation, for example, holds the extra information that you need so that it doesn't pollute the position. So here I think that, so each one of these would be, so that you would be the rows of the 3 by 3 matrix, where which one contains the axis, the axis, where the position is on the diagonal. So the basis 0 would be the 0 index, the x position. Basis 1 would be the second index, or the first index if we're starting from 0. And the third would be the same, so x, y, z. So just doing the dot product of this with the vector, and then increasing the origin and creating a new vector of this. Don't remember what does this mean? I think it's just doing the dot product and then just increasing by the origin. So it's probably just a normal transformation. So whenever you want whenever you want to change the state of the transform 3D by a vector, you just multiply by this. It's just maybe, yeah, I think. I think that's what's going on. But I'm not really sure because it's not really scaling. So I think it's just transforming. But I'm not really sure if there's a word or phrase for this kind of thing. like if I'm thinking correctly, then translation should be changing the origin, not the other stuff. Yeah, but it's gonna change the entire row somehow by the vector. Yeah, by the dot product with the vector. So let me see the rotate. So I have the axis, and then this creates a new basis. It's probably gonna create the matrix, the sine cosine. You already looked briefly into this. So here is for a generic vector, generic axis, so I understand what they do. So this is like the base of the coordinates or the vector that you're rotating from, and then here is just normal rotation. This is gonna be the x, y, and z, I think, positions. And then these other values are gonna be just the rotation matrix that I showed there in the beginning, the picture. It's gonna distribute sine or cosine through, so that when you multiply a vector by the matrix, it's gonna give the equation that is gonna rotate a point in 3 dimensions. So yeah, it is kind of confusing. Yeah, whatever. So I'm gonna spend some time on this later. Obviously, like I understand on the concept level what is happening, but the nuances here, I don't understand why they implemented like this. It's like the matrices there are for specific rotations, but if you want to rotate, I don't think I don't think I've seen a matrix for rotation on any axis, generic axis. It is just like nuances of, but it's still like maybe I should spend time trying to understand this. Yes, like I don't understand why here they are getting the to the power of true, let's say. I guess it's minus 1. So it is 1 minus the axis to the power of 2 times the cosine. So obviously this is going to determine, so it's kind of like doing interpolation on a rotation. So 1 would be the entire rotation, and 0 would be, no, 0 would be the entire rotation, 1 would be no rotation at all. So I guess this is the position, and because this is going to be the position of where the thing is at, where the basis is located. And the rest determine the rotation. It's basically the same logic here. This, I'm gonna look more into this, I think, some other time. And let me see the distance. I'm gonna write down the distance exactly and try to copy everything. Just see if it works there. And the thing is, I need to get it from the after I do something. But I think after I do something, the problem is that like after I trigger the events that is gonna update everything. I might have missed already the thing, but maybe not. Maybe it updates again, so I'm gonna test. So this might be the parts that I'm missing there on the other. Get the basis, column 2, normalize. The column determines the axis, so obviously it's gonna be like that. So it's making a plane based on the camera Z with the origin. So this is getting the distance from the plane that is made out of the camera origin with the camera Z. You can imagine that the Z, so the Z is where the camera is pointing at, and the origin is where the camera is at. So the plane would be like obviously the intersection of the two, like the connection of the two. And the other transform is this other thing here from the spatial editor. So the position of the spatial editor. So it's getting the distance from the plane of the camera into the spatial editor here. And it multiplies this by the camera Z. So camera origin plus. So I think it's translating. So it unprojects and gets that way. I'm not 100% sure though if this is gonna be related to the orbit from the camera. It might be though, because of that. Thing is that it doesn't change anything there. That's the problem. So it doesn't change this value here. And maybe it does inside of the function though. It's just passing the index and changing. But I think, yeah, it doesn't make sense for that to be making correlations. It's also kind of weird that it takes the y here. So it's adding to the origin the z direction multiplied by this gizmo by the delta. So it's the difference. So it's the difference from the plane of the camera multiplied by the camera z, and then increases the origin from that. It's kind of weird. And yeah, the thing is, I'm not 100% sure if it is related to the orbit there. So I think here these offsets, I don't know for sure. It has something to do with the viewport, I think, but I'm not really sure. The 0 is probably the X, I think. It has to be the X, and the 1 is the Y axis. Not sure what's the purpose of the offsets. A 0 here. I think this is just the dot product. So it's basis multiplied by the vector that is minus this origin here. Yeah, so basically it's the dot product, but decreasing the origin. So here's adding and there is decreasing. I think that's this is probably the I think this is probably the thing that displays the axis of the camera, like of the editor. So it's not directly related to the camera, but is related to visualization. Also remember seeing some stuff here that is related to the grid that they display. I think this might be that ball with the axis in the middle of the visualization, probably. So I'm just gonna go over this. I wanna avoid spending a bunch of time trying to understand the nuances of this before knowing exactly if it is directly related with the stuff that I'm trying to do. So I need to make sure first, but that's kind of the hard part because obviously I don't know. So, but I wanna. I think there's probably better ways to see if I can find exactly what is directly related to setting the or to changing the orbits and to translating the values of the cursor into the final value of the camera. So I want to press F5 now. So again, this stuff. I'm pretty sure that this is gonna be like this is the function that changes the values there. But if this is the function, then I'm not really sure if I am doing the correct thing there. It's just weird because of the visualization, or if it's something else. Yeah, I think I forgot to. Oh no, the position is 0, so I can try to do the vector 0 there. Probably because I don't have a lot of time left, I'm just gonna try to do this. Yeah, I have 1 minute, so I'm just gonna try to implement this there on the other one. But it's probably not gonna work because I believe I tried this before, so I'm gonna have to try something else. So let me see. I think the next thing that I'm gonna try is just press because this is another problem. I'm not really sure if I'm gonna be able to. I might have to disable this breakpoint here so that I'm able to move the visualization on the editor so I can start the step over from the points after I move the mouse there. Let me paste this stuff here. So usually what I've been doing is just commenting the previous one. Once I figure out one of them, then obviously I'm gonna delete everything. So I'm just gonna copy the stuff that I have there. Yeah, it's obviously gonna be this one. Let me think. Because it's perspective, projection. So this one was vector 0. And this was 4. And these ones, I think they are, I'm pretty sure they are the relative mouse position. Because I've seen there the orbit, and I think that's how they get the position there. I think that's pretty much it's so yeah. Press F5. In order to compile the other one, I need to stop this one. Otherwise, it's gonna complain about access denied here, I think. So this is the last thing that I'm gonna try today. But I think that this approach is basically the same that other people recommend, and this is the one that I was trying to do there. Which seems that is not working. Or maybe it is working, it's just like for whatever reason it looks kind of different. It might be because it doesn't have the coordinate axis or it doesn't have the grid in the bottom. But I think it's basically the same logic as this approach here. Translate the camera to a focal point, then you rotate based on the mouse. The delta of the mouse, which you get from the get relative events. From input event mouse motion, you get from get relative. I tested to see, and I'm pretty sure that this is the one that already has the delta of the mouse position, so you don't need to subtract. Because another thing you can do is just get position from this event here, which happens when they click, and then you set the value, which I try to do here. And then you get the delta by the movement here, and then you just update. But I'm pretty sure this is already the delta, so it should be the delta of x and y, and is rotating the transform. The only difference here, this might be what is wrong, is that here you have to set transform. Yeah, this might be the problem. But I don't see why this would be the problem. Because I'm pretty sure that I tried like this as well, the previous time. So I'm gonna try this. I'm gonna try to compile and see. So if it doesn't work, I'm probably gonna come back tomorrow, or maybe if not tomorrow, then 2 days from now, and then just spend a bunch of time stepping over this. and trying to see if I can figure out if there's something wrong. And yeah, if it doesn't work, then I just move on to other stuff and leave it like this. I think OBS kind of interferes with the thing. Usually it takes some time, but I think when I'm streaming it takes more time usually. Because OBS probably works with the same rendering thing. Probably not sure if they use Vulkan, but I'm pretty sure OBS uses Qt. Yeah, it's obviously not working. Yeah, so I'm not really sure what's going on. It might be the sensitivity though. Yeah, but I don't think it's the sensitivity. Because the direction seems to be off as well. That's the problem. Let's do a very small value here. So I remember that when I was slapping over that, the value that they get the radians from is 0.25. So they pass 0.25 to the radians, and then they get an even smaller value for the rotation. But I think that's not the problem. So last time, it's probably like the inverse here as well. So the X should be the Y, should be rotating the Y. Or maybe not. Not sure. Oh, this should be minus as well, I think. Oh, but this is a problem. So this is like it seems that this is how they are doing there, but it makes more sense for these values should be the opposite of each other. Because obviously you don't want the camera to move forever, so you just get further and further away, for example, which I think is what's gonna happen here. So one potential reason might be because of the translation. So like they build this transform, but for whatever reason is different when you translate the transform to the camera, the way that they do there. It might be that I have to do this thing here. So I have to see what they do inside of this set global, which is multiplying by the inverse there. Or maybe this is what I have to do. Or I just call this function directly, and then I pass the transform there that I have, and then I set the transform. So it might be because of that. Yeah, I think it might be because of that. So I need to put this transform on the global thing. So let me try that. Oh, that should be inside. I think this is the last thing. It seems to be very fast. Let's put it like this. Last thing that we're gonna try. Oh, maybe setting global transform is already updating. Yeah, so maybe instead of set transform, is set global transform. I think that makes more sense. So I'm gonna replace this, this. Yeah, didn't work. So this is what I was saying. Like, doesn't make sense to just translate here. But this is what I don't understand. Is that like that's how it seems that they do there. So obviously there's like more stuff to this. It might be because of this stuff here, or it might be because of something else. Not really sure. Or it might be because I'm looking into the wrong thing, because I do remember that. I think on the comments there, they say this camera cursor is only for interpolation or something like that. But I'm gonna stop here. I'm gonna continue this another time. So, see you then.